we learned about on this very note, event paradigm, the event system nature of Node. What if Node used the event message broadcasting pattern, where it flags out a message depending on stuff that happens in Node, to auto-trigger a function, to send out a message event each time a sufficient batch of the JSON data had been loaded in. And then at each point have that auto-run a function, and that function can start cleaning that batch of data, store it. While we're running that function, cleaning that batch of data, Node is pulling in the next batch, triggering the function again to clean that. And we're effectively going to end up doing these in parallel. While we're pulling in batches, we're going to simultaneously be running the clean tweet function batch by batch in here. I can see this reducing our time down to, I'm going to have a feeling, 15 seconds, basically, because we're going to spend all the time we're pulling in batches in the background, simultaneously cleaning tweets in the foreground in JavaScript, which is only going to take 10 seconds. So we can do all of this while this is happening in the background in chunks as it comes in. Should be pretty cool. I'm going to feel there's a bit of an issue, though, because the data is going to come in chunks at a rate. Oh, I think I'm going to switch this up. Actually, it's going to take 20 seconds. There we go. To clean that much data. The data is going to come in, auto-trigger a function to run on the next batch, but the running of the cleaning of this batch won't yet have finished. So is that auto-triggered function allowed to jump in and run at the same time as the previous one's running? No. But it can't just be it's not allowed to. There must be some really, really strict rules for when it's allowed to throw the next running of the function in. And that's going to introduce to us some queuing stuff. We're now going to start working on things in batches. I love this. I think this is absolutely beautiful. By the way, what are the batch sizes? Well, we can control it, set it ourselves, but the default batch size is 64 kilobytes. They call it the high watermark. That any read flow of data, I'm going to show you, by the way, why I don't think they're called, well, we'll get to the read stream thing in a second. I don't consider them streams of data. They're batches of data. They're brought in at chunks of 64 kilobytes. Doesn't sound like any stream I've heard about where you're like, well, we'll see this in a moment. Well, actually, I'm going to see it right now. This is, to me, what a stream looks like. And I did once do this and drew out an entire bucolic environment with a full stream. But I'm not going to do that this time because that was a real waste of time and a massive distraction last time. Just a little bit of a stream. So here's what, to me, a stream looks like. There you go, see? Definitely not drawing out the whole thing this time. Just a little bit. Oh, that's a volcano in the background. No, okay. That was meant to be a tree, but that was meant to be... Look! Artistry is not... I talked about this before, but this is my favourite thing. I'll never forget when I was 6 years old, when a girl in my class said, I said, can you draw a cow? And she drew, her name was Emma. I still remember her. Emma Try. She lived down the street. Shout out, Emma. She lived down the street. She went to the same church as me. Emma, I sang in the choir. Anyway, moving on. So Emma could draw a cow, and I tell you, if any of you try to draw a cow, this is something very real for me. If you try to draw a cow, you cannot draw a cow. Like, it will look like a horse or a dog, and it's very fascinating to me. So anyway, that was not much to that story, except for she could draw a cow. Maybe let's see if I can draw a cow. You know, people pay subscription for this. People actually pay subscription. Okay, there we go. That's why. Okay. No. Who said no? Virginia. You're just like the Virginia in my family, constantly undermining. No, she's great. All right, so this is what a stream looks like to me. It's a constant flow. Whereas actually, what a stream is in Node, and honestly in computer science in general, is chunks of data. So we're going to get them, like, think of it instead of pails of water, you know, pails, but that's the oldest. You only ever say the word pail when you're talking about, okay, buckets of water with 64 kilobytes of data in each of them. I think that's really important because the idea of a stream sounds so intimidating. What? Flows of data racing towards me. How am I going to deal with them? I don't have to. Instead, they come in as buckets, and each time a bucket arrives, I'm going to flag an event. Node's going to auto-broadcast a message. What is the message? What can anyone spot? Zep, can you spot what the message might be?
I think it's data.
It's data. It's going to broadcast a message, data, and we're going to have a function attached to it to auto-run at that moment. Back in JavaScript. Again and again and again. Okay. So I just think the word stream sounds so intimidating. It's like it's flowing data racing towards me. How can I possibly write code to handle that? I don't have to. I have a little... Matt's like, nah, that's fine. But to me, I think it's very important. It's not a constant flow that's unwieldy and out of control. It's a batch of data that we get to set a function that will auto-run when a batch completes, when a batch fully gets into Node and gets executed. Okay. By the way, people, this is Node's pride and joy feature. Node is so proud. Andrew, go ahead.
Is the data pre-batched in 64 kilobyte pales before Node interacts, or is Node like counting, like a bouncer, boom, 64, hey, we got data, next one in?
It's handled by Node.
Cool.
Yeah, this is Node's pride and joy feature, people. This is a feature of Node that people are like, oh, wow, because they can see the efficiency this gives you. Like, this is super efficient for when you're handling large-scale data and want to continue moving in a single-threaded environment and not block any further code running. People love this design pattern of Node. It's like its pride and joy feature. Along with the auto-running stuff, this is probably its most important feature. Okay, let's get using it now, though, because we really got caught up there. That picture, I just don't think it's a good move to spend the time on it. And I don't know, I felt like it was a good decision at the time.
So is this feature why Netflix uses Node?
Actually, that's very interesting. Exactly how video is passed to a client can be done, yes, in chunks, and you can certainly use Node for it. But when it comes to video servers, people use very dedicated other specialized technologies often to handle serving up video. And when it comes to video streaming, that is where you're streaming messages, video, between two users, like we're sending a video chat. We don't even use the TCP, which is the standard under the hood format of rules for passing data back and forwards between a browser and a server on which HTTP sits. We don't even use this protocol called TCP at all. We use a totally different set of rules for how you pass data back and forwards called UDP, which is more suited. Let's just do this bit, and I might tell you TCP versus UDP in a second. It's a good thing to know, but let's just do this for now. We have our tweets.json here. People, we're almost there. We have our tweets.json here in the file system. We're now going to get super smart about how we go about accessing this, running code to clean the tweets that we get out of it. Let's go, everybody. Line 1, what are we doing? Virginia, what are we doing in line 1 there?
We are declaring a label called clean tweets.
Cleaned tweets.
Setting it equal to...
Big old empty string. Excellent. Next line, Sarah Rose.
So we're declaring a function clean tweets.
Clean tweets, exactly. Clean tweets is a whole function definition. We're just saving code to probably be auto-run. Oh, no, we're going to run that one later on. Okay, next line, William.
Declaring a function called doOnNewBatch.
Aha. We're never going to be the ones running this function. This looks like it's going to be our auto-run function. DoOnNewBatch. Excellent. Thank you, William. Rich, next line, left-hand side.
Declaring a constant called access tweets archive.
Okay, people. Now I want you to all... So access tweets archive. Access tweets archive. Let's make sure our call stack's set up. There it is. Okay, access tweets archive. And the right-hand side says to use which Node C++ feature, Zep?
FS.
FS, exactly. And specifically, make a connection to tweets.json. So, access tweets archive, run fs dot this create read stream. There it is. And pass it tweets archive.json. Just a string of characters at this point to JavaScript, but to Node it means something. Okay, this is going to do one thing in JavaScript and one thing in Node. Raise your hand if you want me to tell me roughly what it's going to do in Node. Charlie, what's it roughly going to do? There you go, didn't get to raise your hand. Charlie, what's it roughly going to do in Node, the create read stream, do you think, with this piece of information about the where to go look? What's it roughly going to do in Node, do you think?
Tell the file system to load that file.
Fantastic, exactly. It's going to say, actually it's going to say to libuv, set up a dedicated thread to go and get this data and start pulling it. Okay, what's it going to do in JavaScript? Remember that thing we dwelt on for quite a while? It does in JavaScript. Raise your hand if you can tell me what's it going to return out in JavaScript immediately. Yeah, Sam.
Object with methods.
That
will tell Node to do certain stuff.
Yeah, to edit what we just set up. Fantastic. Very nice from Sam. Yeah, that's a real tricky one. That's honestly really, really tricky, that bit. I think, yeah. So it's going to, in JavaScript, return out in JavaScript into Access Suites archive an object full of functions, methods that have a connection to this particular opened stream of data or open access point to this particular file. I should have said, actually, if FS was set up to go look for. Thanks, everyone, for saying so attentive on what hopefully now is starting to feel boring. In a sense, because Matt nodded, fortunately, just before I said the word boring, so it wasn't actually in response, perhaps. So to start to feel boring because it is just the same thing again and again at this point, but all of Node is this. Okay. The only thing that's not like this in Node is that you can technically split up all your JavaScript code into different files and then bring them all back together using the require and the module pattern that we're not going to get to cover today. It's pretty clear at this point, but we will cover in a future talk. That's the only thing to me that's not this model of trigger background feature, set up auto run function, have it auto run when the background feature finishes its work from the file system or whatever, or the inbound message, have auto inserted data from Node again and again and again and again. Okay, good, all good. Now, we need an auto run function and we need it to run on a certain event. An event that gets triggered every 64K batch, 64,000 characters from the JSON file. And that is going to happen in the very next line. We're going to use access tweets archive, which is the object full of methods that give us access to this background feature. Let's make sure that's clear. I'm just going to have a little star there to show that it accesses this particular background feature of FS, not feature, sorry, this particular instance of using FS in Node, the one that's set up to access this file. And we know that, we should say that FS read stream does this automatically. At 64 kilobytes, shout out what event, Zep?
Data.
Data. There it is. At 64 kilobytes, that's done by the FS read stream by default. We can change that, by the way, they call it the high watermark. We can change that. I have to look at the docs, but you change it by passing to read stream as second argument, first argument that it will ignore if there's nothing there, which is an object with a property you can put high watermark is and some value, which will set up what the batches are. Okay, so optimize, make sure you're optimizing, when you run the function, when the data event gets screamed. Okay, but now let's use access tweets archive. Access tweets archive .on and determine what function we want Node to auto run when that data event at 64 kilobytes gets triggered or gets screamed, emitted. Emitted, there you go, that's a technical term, not screamed, emitted, or broadcast. They're both good terms for it. And then pass, what function do we want to have auto run, Andrew? Can you spot?
Do on new batch.
Do on new batch, thank you, ma'am. Do on new batch. We pass all of its data in. By the way, just as a side note, everybody, what actually happens is we pass a reference, such as a link, back to where this function was saved, just in case anyone thinks we're copying all the code into here. We're just actually saying, make a link up to this function, have it run, just so we know. It's just a little side note. Okay, in it comes. So on the data event being screamed, auto run, do on new batch. There it is. Okay. All right. And let's introduce our time going by now, because now it's going to really matter. So we're at like roughly 0 milliseconds here, I say. Okay, or one, whatever, roughly 0 milliseconds. Okay, now, by the way, the stream only starts getting data once we set an on data event. It doesn't start grabbing data from there. It doesn't start. It sets up it goes and finds it, the file. It doesn't actually start pulling data until we say what to do on the moment of that data arriving in its first batch. Otherwise, it would just be pointless to pull it in if we haven't said to do something. So it won't actually even go and pull it in until we say on. And then it does. And the first batch arrives. And I'm going to do it in blue, I guess, because it's coming from the file system, I suppose. And the first batch arrives. Yeah. First batch arrives, and we're going to have the auto created and inserted data. The first batch arrives of 64 kilobytes of data. 64 kilobytes of data. And it's like, what was it? It was tweet 1, hello, and so forth. Okay, the first batch though, or not, I guess not the closing curly brace because it's a massive JSON object. The first 64 kilobytes, first 64,000 characters. In its come. What's going to be triggered? The data event. A data message is going to be streamed out. What function is going to auto-run at this point? Mohammed. What function is going to auto-run at this point? Michael. Bavit. Do on new batch. Do on new batch. Excellent. And up it comes. Do on new batch. And look at this, people. Our input, there it is. It's our data. There it comes in, the string. We create a new execution context. Are we still in global? There it is, global. We have do on new batch. We have it auto execute. We have it auto execute. It's going to auto execute. There it is. Create an execution context for it. There it is. Into it we go. In the local memory, we have our first argument. Our first parameter is data. Our first input argument is the underlying tweet data. I'm not sure I'm doing it in blue now. I guess it's coming from the file system rather than from Node, but it's kind of I don't know, whatever. Now, technically, people, again, it comes in as a stream of zeros and ones, known as a buffer, but we're just going to, for now, represent it as stringified JSON. As JSON, there it is, tweet 1 with hello and a lot of other data up to the end of it. Up to the end of the first 64,000 kilobytes. Now, we reached this after, what's 64,000 kilobytes going to take? It's going to take like 6 milliseconds. Is that right? Not even that. Like 1 millisecond. About a millisecond. It's very, very quick. So we're at only 1 millisecond now. Look at this, people. Not after 15 seconds, but after 1 millisecond, we started cleaning data. And we do. What do? We're going to run clean tweets, the function we saved. Clean tweets, take in the data, and return it out return it out, cleaned of the nasty words, and append it. Where's Sam cleaned tweets? Cleaned tweets. Is that in local memory?
It's in global.
In global. And that's where we're going to take the first cleaned batch of JSON formatted data and put it up here into that long string, or that empty string at that point. Let's make sure we put clean tweets on the call stack because we were running it. Clean tweets. Okay, and that took us, I don't know, it took us 0.5 milliseconds, whatever. That's how long it took us to run the cleaning. No. No, it took us. These things are a little bit arbitrary, but they are intentionally. They're intentional. It took us 1.5 milliseconds. Slightly longer than it took us to get our 64K kilobyte batch in. Matt, go ahead.
So with this, we can't necessarily guarantee that it's going to be the same order, read and cleaned. The clean tweet isn't necessarily going to be the same order.
Well, maybe it will be, because here's the problem. Well, now, before we you know what, people, let me just take a step further back. Before we get the data cleaned out, sorry everyone, in this execution context, where the cleaning is happening, we're not sure how it's doing it, but it's taking a bit of time to parse all that code and pass all those strings and find the the bad tweets. While that's happening, you won't believe what's happening down here. What do you think's happening, Zep?
Sending the next 64.
The next 64 kilobytes arrived. The next 64 kilobytes arrived in. And it's continuation of the string of data. What event gets triggered down here when the next batch arrives? Bavit?
It gets called to...
What event gets triggered?
Do on new batch.
Data gets triggered, exactly, Michael. Which triggers?
Data on new batch.
Do on new batch, exactly. And it's ready to run. And folk, I'm going to introduce this here, but we're going to see it in greater detail as the last big portion of what we do. Now we have problems. We have a function that was auto-run and is running another function inside of it. And while that's happening, at about, 3/4 of the way through the cleaning of that first batch, that clean tweets function is running, about 3/4 of the way through, do on new batch wants to run again. And auto-run in here. Can it auto-run straight away? It would literally have to sort of pause the running of this function. This is Matt's worry. He's like, hold on, would it run and finish sooner, or? And this, people, is where we start to need rules for Node for when an auto-run function from Node is ever even allowed to run. And we're going to see this in sophisticated detail. For honestly more intellectual reasons, there'll be the odd case in reality you'll need to, well, there's many cases you'll need to understand it, but for senior dev and even mid-level dev Node interviews, it's crucial you understand it. This is where we really need to see it just for our regular day-to-day working with Node. And I'm going to start off with a simple explanation, or simplified, not simplified, no, ignoring quite a few pieces of what the rules are for when that auto-run function is going to be allowed back in to run. Because we've now had it run at, what was it, like 1 millisecond? And now it's 2 milliseconds and it wants to run again. But we're at 2 milliseconds, 1 plus 1.5 milliseconds, we're still in here, cleaning the first batch. You feeling frustrated, Michael?
Very.
Yeah, Michael's frustrated. Michael is the mayor. Oh, I'm not allowed to talk about this. He's a mayor of a major sub... No, I'm not allowed to talk about this. Okay, not talking about this.
No, you can't. That's fine.
Oh, he's proud. He's a very great mayor. It's an honor to have him here. And he's frustrated. So you can only imagine what the non-mayors among us are feeling. Powerless. Powerless. Don't panic. Don't panic. Turns out, with actually the help of Node, and particularly the libuv library behind the scenes. So I'm actually going to do it in purple. JavaScript, with the help of Node, has set up queues. Queues. We'll start off with one queue. A queue, we'll call it, because this is a function that was passed into another function, it's known as a callback function. Any function you pass into, we pass do on new batch to be run later on, to be called back that was horrible, call back into JavaScript. We call it the callback queue. I'm going to be more specific on this later on because there's quite a few of them, but for now we'll say the callback queue. And so at 2 milliseconds, when the next batch arrives, triggers out the data event and says run do on new batch again. 2 milliseconds. We do not take do on new batch and start auto running it. Where does it actually go, Michael?
Callback queue.
Into the callback queue. Exactly, into the callback queue is where it's going to go. And it's going to have to wait there. Do on new batch stored there. While we continue running code here. So let's finish up running the code. The clean data does come out and gets appended to what global variable, Sam?
Clean tweets.
Clean tweets, excellent. And it's got like, I don't know, still a string of 5. We didn't JSON parse it yet. We're just leaving it as a script. We're going to append the next piece of the string to JSON parse it in one go. When we've done that, we'll do that at the very, very end when all the data's in, but we're doing the cleaning as we go because that's the bit that takes a long time. And into it is tweet 1, hello, and so forth. All the data there. And we've exited clean tweets, the function we were running. And so it gets what, Zep, in terms of the call stack? Popped off the call stack, exactly. And we go back into the running of do on new batch. Well, there's nothing left to do in it. So it's also popped off the call stack. And now we're back to global. Okay. And now we must introduce, because what runs next? The whole time in Node, before any line of code, any function gets run, Node is going, with the help of libuv, let me check. Is there any code, and we're going to see this in much more pure detail later on, I just want to introduce it for now. Is there any code that we've commanded to run? Any code that's currently sitting running on the call stack? Or is there any global code to run? Those two conditions. If the answer is no, then start checking the queues. That's like a Frank Sinatra reference. Start checking the queues. I like that, sir. Raise your hand if you got that reference. A small subset. Do you want me to sing it? Yes. Start. Okay. Okay. Big mistake. All right. And this checking of the queues, once all global code or any code we're running is finished, this checking of the queues, it has a built-in feature that does that, built by libuv. And it's in the browser version of JavaScript as well, but there it's built into the browser. But we don't have the browser here, so we had to build it from scratch again using libuv. And it's known as what?
Finish.
Event loop.
The event loop. The event loop. It is the Node, with the help of libuv, feature that looks at what's in the queues, sees what's awaiting to run. Oh, I'm ready to run. I'm ready to be auto-run by Node. Checks there's no code currently running, and then grabs from the callback queue. We're going to see there's quite a few queues it gets to choose from. We'll see a few of them after the next break. We may even hint at most of them. There's a total of 6 queues that it gets to choose from. Nice. We're probably only going to see 2 or 3 of them because most of them we just don't use most of the time. But for now, 1 queue sees what's in there. It checks, is there any code left to run? No, we got rid of do on new batch. We finished running the last time. And at whatever it would be, 2.5 milliseconds, because we were ready to run it at 2 milliseconds. But we were still inside this function here. And so do on new batch, the next running of it for the next batch of 64 kilobytes, had to sit waiting. But at 2.5 milliseconds, it goes, yes, you finished running do on new batch, the previous running of it, in which you were running clean tweets, all finished. And so grab the next running of do on new batch and put it on the call stack and run do on new batch. Again, create a brand new this is the moment to awaken ourselves. Michael's on his phone. Create a brand new
Execution contest.
Did we make it?
No.
Who made it?
No.
Node. Good. There you go. Execute it. Execute it. And we're not going to go into the detail. Its input is the next batch, right? It's the second batch from the stream. The next batch is 64 kilobytes. The second one, this was the first batch of 64 kilobytes. The first one. There's a second one. Clean it, append it to clean tweets. And at the very end, we would then want to JSON parse that clean tweets. Look at this, people. We're lining this up beautifully. We're lining this up such that we're able to start parsing and working on cleaning tweets as we go. No longer are we going to have to wait for all the data to be finished at once. Now we can pass in the data, start cleaning it, move on. Pass in the data, start cleaning it, move on. Pass in the data, start cleaning it, move on. This is Node's favorite feature. This is the feature that allows it to start working on things before it's got all the data in hand, but to work on it in terms of it being batches or chunks of data. And by the way, all background features, or most of them, technically, not all of them, but many of them where you're flowing data in and out are really just batches, chunkified sets of data. And if you see the HTTP one, well, for a tiny little thing like a GET request, it's just one chunk. But if it's sending back a bunch of images or a movie or whatever like that, then it's going to be sent in chunks out of the socket using this model as well. Okay, and how do we, on a chunk being complete, get access to it? Using Node's event system. That whenever a chunk gets in, it auto-triggers the data event. We get to work on that data and continue in the background bringing in the next chunk. And when it's done, work on the next batch. And by the way, people, I will say this, I contrived this so that it took a little bit longer to clean the data than it took to bring in the next batch, just so we could see a function being blocked from running, so I could introduce to you the fact that we need to queue up functions to run in JavaScript. I wanted to start introducing that to you now because it'll make the final slides, I think the final slide's coming up. Yeah, the final slide, more accessible if we've already been introduced to the notion that we have to queue stuff up. Auto-run functions have to queue up before they're allowed to run in Node. A little bit contrived. I actually reckon that there's no cleaning function that would take longer than the time it would take to get 64 kilobytes of data in. That's going to take longer than any cleaning function, I would suggest. Which would mean that actually we would end up, if, I hope you all, this is a little bit of a sidebar, people, it's not too important, but if you said this is the time, what was it we said, 15 seconds to get in all the data, and then we were then this is the time to get all the data in, 15 seconds. And then we were, once the data came in, cleaning for, we said 20 seconds, but actually in reality it would be more like, let's say 10 seconds. We were cleaning it a total of 25 seconds. If instead we're doing this, where we're importing, cleaning, simultaneously importing, cleaning, then we would finish at this point. We'd finish importing or clean that last little batch, and we would be finished in just 15 seconds. This is a little bit of a bonus for people. What's most important here, and what you want to take away from this, is that we can break down any inbound flow of data into chunks, and on each chunk, run a function on it to do it in that batch. And then while we're doing code up here in JavaScript, our single thread of JavaScript is running away. Good to go. In the background, we've got a spun up thread by libuv that's pulling in the next data. Think of it as, it's definitely multi-threaded, just not in the same runtime. JavaScript's got one thread. and libuv spun up a background thread. Okay, folks, let's have thumbs on what's getting pretty advanced at this point. You lost me at this point. Clear clarification. William's clear. Bavit's got clarification. Sam, you're clear. Michael's clarification. Zepp's clear. Sarah Rose is clear. Virginia's got a clarification. Matt's clear. Okay, so we've got Charlie.
All the events, they share the same callback queue?
All the associated functions with events, you mean? All the associated functions, unfortunately, all functions that have been set to auto-run by Node do not share the same callback queue. That's what we're going to see. I'm just thinking if all the event-driven ones do. I/O ones do. I think timers trigger events. Are they? That's a really interesting question. More importantly, all functions set to auto-run do not share the same queue. Any ones that involve input-output, known as I/O, that is ones which do trigger events, they all do share the same queue. My question just to myself is, are there some auto-run functions that do not have events that trigger them to auto-run? And those are the ones we're going to see in a moment. We'll come to it in a second, Mark, if you don't mind. Let's just do the ones here. Matt? Oh, Roman, okay, fine, go ahead.
Once it's finished reading a file, does it send any response, kind of a message that it's done, like the end?
What a great question. Absolutely it does. Anyone know what the flashed out message is? Because we're going to need that, right? Because we're going to run at that point the JSON parse, presumably. Yeah, it's going to auto-close it, and it's going to shout out, close. It's close, isn't it? I mean, the point is we go and look in the docs to see exactly which event it flashes out. I believe it's close. At that moment, it's going to, we hopefully set up a function to, on the close event, handle the data. Is it close?
It is.
Good job. Yeah. Yeah, exactly.
It's right here.
Yeah, on close, exactly. On close event, run a function which in this case would presumably take all the stringified data, stringified JSON, and turn it into an object at that moment, once we've got it all recompiled together. Yeah, great question. Thank you, Roman.
So it will always deal with a string, whatever file we give it to read, or?
Again, I'm being a little bit cheeky here, Bavit. This doesn't come in as a string. It technically comes in as what's called a buffer, which is a space in memory in which you fill in zeros and ones that represent any data type. And once you grab the first bit out of it, you throw it in with more zeros and ones representing the next batch.
So my question is, since we were
There's a buffer data type built into Node.
Since we were reading a JSON, right? So it started reading from the beginning, but it didn't close the file because it just took a chunk of data from it. How does it know that it's a complete object, or?
This is what I said. We're going to hold on the parsing of the JSON until we've done all the cleaning. So you can imagine what we do is we can turn the buffer into a string. The buffer is just zeros and ones, 64,000 zeros and ones, 64,000, bytes, which is 64,000 characters. Turn that into a string, remove all the mean words, attach that to clean tweets. Next 64,000, do the same thing, attach it onto the end of clean tweets. Next, hundreds of 64,000 kilobyte, 64 kilobyte batches. The whole thing is now a long stringified string of data. Then we apply JSON parse on the close event, which is when all the data's in.
So that means only operations that we can do is if it's assuming it to be a string, right?
We wouldn't be able to start parsing the data because a JSON stringified JavaScript object, you really do need to have the opening curly brace and the closing one to be able to work with it. Right. So you couldn't do things, like working with the JSON to kick it. Yeah, very fair. Yeah. Other questions? Michael?
Yes, I do have a question. So the browser's connection to the server socket times out after a while. If this takes 15 seconds, would that happen? And if so, does it make sense?
We're doing this. I'm assuming we're doing this before any requests come in.
Okay.
Yeah, we're not grabbing in 1.5 gigabytes in response to any user's request anytime soon.
Okay. But you could send a chunk.
From it, if it's like
client,
absolutely.
Send another
video data, you could sort of send pieces, although HTTP has ways of working with video data that this doesn't necessarily imply.
Is there anything that can delay adding a data stream to the callback queue so that things get out of sync?
Wow, that was much more. I'm very intrigued by that. Here's the thing, man. Yes, because it is a single-threaded language, including the node passing stuff into JavaScript. Meaning, we're not going to go into too much detail until the final slide, meaning that function is only actually literally put on the callback queue when things are put on the callback queue at a certain moment. The moment being when there is a break from synchronous code running. But it could never run anyway until the synchronous code is run. It can never run anyway until the synchronous code is finished running. So who cares? That function could never run anyway until all the synchronous code is run. So when it gets added here, doesn't matter, as long as it's added in the order of completion, and libuv handles logging the order of completion of functions being ready to be triggered. They're actually, yes, technically, although we don't need to worry about it in my opinion, technically added to the callback queue only when the event loop does a cycle and there's no synchronous code. We just don't need to care because they were never going to be run until all synchronous code was done anyway. So who cares when they're added? It's when they're executed that matters. And they're always added in the order of completion down here. They're always queued up and then grabbed out in the order they finished, or the order they were triggered, to run, auto-run down here. We'll see more of this in a moment. So we're hitting the very limits of what we have in terms of information for the event loop and the callback queue. Final thing after the break will be a monstrous full event loop, and we'll do as many of the queues as feels comfortable. And that'll be the very final code. Mark.
What would you do when a partial word has arrived?
Yeah. I mean, you could do a smart thing, like if you spot a word that hasn't got a closing quote on it, you could make sure you just have it as a little cache, as a little separate string here, and then append it to the beginning of the next batch to analyze it as a full batch with full words. So that would be more of an implementation detail, how you ended up handling that. Okay, does everyone get that? What I'm saying by that is if the stringified came in and you cut off halfway and that word was F, it's the word letter F followed by letter U, and you're like, oh, this is great, it's my favorite two-letter word. You'd miss that actually there's a word to be cleaned there. How would you spot it? You'd make sure you never, you always end on a space, for example, or you always end on a closing quote. And this is just a parsing challenge that anybody faces when you're parsing data. You make sure you always end on a quote, always end on a string, and then go back to the previous space or previous quote and take that word and just cache that. Cache, I mean, like hold on to that word as a end of previous string hangover and save it, and then append that to the next block, the next batch.